Welcome, everyone. I'm Tim Stewart. With me, I have Bob Sloma from Sandalwood. We're going to be talking about how to transition from legacy systems to inductive automation, ignition system in a seamless way. To kick us off, Bob, can you share just a little bit about yourself and Sandalwood?
Yes, so I've been with Sandalwood for 7 years now, as of this month. I've got over 30 years of experience in various manufacturing roles, all the way from started out as an engineer, but moved through not only operations, but also IT. I also had my own tool and die shop for several years, so I've had experience in discrete, continuous, and made to order type production environments. Sandalwood is a engineering services firm where we've got three main lines of businesses. I'm with the systems integration group, where we help companies collect data from their production lines and send that data off to other systems, as well as provide feedback directly to operators and line management.
Excellent. So as we talk about the goal for today, I just want to throw in a few words here. Thank you for joining me again. We've talked a few times about upgrading from Excel and other systems like that where you don't really have much. I think that kind of closing up this series, it's going to be an interesting discussion about how to transition from whatever legacy systems into ignition with the approach that we're going to take today. So I'm looking forward to the discussion. With that as a backdrop, can you kind of run us through the goal for today?
Sure. So today I want to kind of share with you a structured step-by-step approach for being able to transition from legacy SCADA, MES, and HMI systems to the inductive automation ignition platform and minimize the disruption to your operations as much as possible. I'm offering a migration strategy that basically is emphasizing thorough system mapping, doing parallel testing, and a phased deployment to help preserve both your data integrity and ensure your operational continuity. I want to address some of the key challenges that most people would face, which include maintaining real-time data flow, minimizing downtime, and developing a comprehensive operator retraining program that's tailored to the new interface and oftentimes new workflows. And share the importance of aligning technical execution with stakeholder engagement to help achieve a seamless transition while laying the groundwork for future enhancements that are scalable.
Excellent. So I guess the next question in this topic is why ignition? And so hopefully you can give us a little background on that as well.
Sure, Tim. So I've outlined 6 key reasons why ignition is a good platform to transition to. One, and how it makes it easier to transition. So the first is being ignition supports running alongside existing legacy systems. So it allows you to be able to do a gradual transition between your existing legacy environment and the new environment. Parallel operation helps to minimize your disruptions and provides a safety net during the migration process. So for example, we did a large-scale SCADA migration and developed a plan to allow the client's legacy system to run in parallel with the Ignition application, which enabled a smooth transition without halting operations. Ignition also has a comprehensive tool set to be able to integrate with legacy systems that you still want to keep in the mix. Its modular architecture includes tools like a SQL Bridge module and OPC UA support, which helps facilitate integration between your existing PLCs and your databases. And these tools help enable data logging, synchronization, and bridging between those legacy systems and modern applications, which helps to ensure continuity and data integrity during the transition. Another advantage is we can work towards standardization through unified data models. So with Ignition's support, especially with the Cirrus Link MQTT modules, they support the unified namespace and unified data types, or UDTs. And with those, the organizations can standardize both their tag structures and their data models. It helps simplify the migration process and enhance scalability for the future. So another example is in completing that SCADA migration, we were able to take the tags and convert them to equipment level Ignition UDTs and focus on standardizing both the tag names and the logical grouping of that data, regardless of how it was collected. Ignition also is a flexible and scalable architecture. It's designed to accommodate growth from single site operations to enterprise-wide deployments. And its flexibility allows customization to match specific business requirements, whether it's on premises, at the edge, or in the cloud. And its user-friendly interface and customizable dashboards help facilitate operator training and adoption. We can replicate familiar screen layouts and provide structured training tailored to each user role. That way, organizations can ensure a smooth transition for their teams. And Ignition has built-in security features and web-based access that helps ensure secure remote monitoring and control. And that capability is crucial during migration and allows for real-time oversight and quick response to any issues that might arise.
Excellent. I think that's a really solid overview in terms of why Ignition. The thing I would add on there is from a pricing model, it's really hard to beat Ignition. It's a perpetual license. You don't have the annual fees that you have with other solutions, and the price itself is very approachable. If we look at why should we migrate now? Instead of the future, why should this be a priority given all the competing priorities for people's time these days?
Sure. Before I get into that, I'd like to kind of go through some of the legacy. Do a brief history of legacy HMI and MES systems, as well as some of their pain points. So in the 1960s and 70s, that was when we started to see some early automation. There were some early SCADA systems for remote monitoring. You had some really basic hardware HMIs, and really your MES systems were manual. So the pain points were limited functionality and a lot of manual processes. As we got into the 80s and the 90s, we started to see the use of PLCs and PC-based SCADA systems instead of relay panels for control, and the emergence of graphical HMIs. And MES systems became digitized. But with the pain points during that era they were all proprietary systems, and you were really limited on how far you could scale them. As we got into the 2000s, we started to see more integration and networking, where you had integrated SCADA, MES, and HMI systems. The use more on the plant floor of Ethernet and TCP/IP, and the use of proprietary protocols. So your pain points during that area were, especially as you start integrating, you start having an increase in security risks. You had data silos. Basically, the data in each system was only accessible through that particular system, and you had high maintenance. So what are the business drivers today that are really starting to highlight why you need to migrate now? The first is the demand for flexibility. Businesses are really looking for applications that support the business and the production process, and not the other way around, where the business and the production processes need to bend to the limitations of the application. Companies are really dissatisfied with having to change their operations to make it fit an application or a platform. Data accessibility and integration is another business driver, making it easier to get to the data and easier to get that data to other integrated applications. There's also a drive for data democratization. So easier data access helps enable users to find innovative ways to utilize that data, especially for continuous improvement efforts. And then businesses also want to future-proof whatever they put in today, because platforms and applications need to support not only existing, but also new open standards for data communications, access, and storage.
Excellent. Yeah, I think that with the focus that people have today on digital transformation, increasing the digitization on the shop floor, being able to have the visualization that you should be able to have in this day and age and so forth. I think that what you've given is a good summary of how those things can be improved by moving to a system like Inductive at this point in time. So I guess the next step is to look at the steps to achieve that seamless migration. How can you do that most easily and successfully with the minimum amount of friction in the company?
So yeah, I've basically outlined 6 steps to help achieve this migration. The first is assessing the legacy footprint. So you want to go through and do an inventory of your systems and the dependencies between those systems, looking at your existing PLCs, HMIs, historians, databases, and their respective interfaces, and also looking at the dependencies, like the protocols that they're utilizing, like Modbus or OPC UA, any custom scripts that you've got out there in the wild, and your existing reporting tools. And then you also want to identify limitations and compatibility issues. So what operating systems do you want to be able to run on? Where do you have data silos? And what restrictions do you have for remote access? Next, you want to define your migration strategy. So do you want to do a big bang, or you want to do a phase type approach? So choose your path. You do it line by line, site by site, module by module. You also want to go through and define what your scope is and make sure it's in alignment with what operations needs. So decide what your system boundaries are. Is it going to be SCADA only? Do you want to incorporate MES functions? And you also want to align it within your operational windows and your maintenance schedules. Next, you want to design a migration plan. So one of the major goals is to decouple your visualization from your control logic, and set up a parallel environment and your integration tools. So replicating screens, your tag structure, any alarms that you may have in place, and integrate with legacy systems using OPC UA, MQTT, or SQL bridges. And then utilize the ignition tag import and scripting for the conversion. We also want to look at data integrity and continuity. So you want to be able to figure out how you want to handle your historical data and its migration to a new system, or linking to the existing system, or archiving that legacy data. And then have a validation and documentation practice defined. So validate your tag mappings and your alarm configurations, and maintain version control documentation during the cutover. You also obviously want to minimize your downtime. So you want to perform the migration during scheduled downtime or on mirrored hardware, and use redundant gateways or edge gateways to stage the cutover. Oftentimes, this type of strategy is used for corporate systems where you've got dev, test, and prod type environments. We want to replicate that as much as possible within the OT environment when you're doing the migration. And then you also want to do your testing and validation before you go live. Test your alarm handling, your data logging, and your client screen functionality before going live. And oftentimes you can do that in a test or a dev environment. And then operator retraining and user buy-in. Once again, being able to do operator training within a test environment is a good idea, as opposed to trying to do it within a production environment. And try to get as early of an engagement with the operators as possible, so that they become familiar as soon as possible with the new interfaces. And use parallel screens or demo mode to help train them. And as we mentioned before, you can replicate familiar HMI layouts to reduce the learning curve. But oftentimes we've seen clients want to add functionality to what they've already had. and then also have tiered training programs and really base it on the user persona, such as operators, engineers, or supervisors. And this is a really good time to showcase some of the new capabilities that come with the Ignition platform using perspective or vision's modern features to be able to show what is possible.
Mm-hmm. So um, it's funny because I listened to that and, there was a lot of detail there. But, at the high level, it's pretty straightforward, right? You want to assess where you are today. You want to define where you want to be in the future. And then there are essentially boxes that you need to tick in terms of ensuring your data integrity, continuity, making sure that you're performing these changes when you're not in a mission critical time on the line, and make sure that you address the human aspects of it as well, and give people the resources that they need to adjust to any changes in the system as you do this migration. What are some of the key lessons that you've learned as you've gone through this with actual customers?
So probably the first one and most important, at least out of the gate, is to realize the importance of tribal knowledge. Really, you need to overestimate the amount of undocumented knowledge that's out there around these legacy systems. You have to assume that you don't know everything and that much of the process isn't documented. And as you're going through the planning stages, trying to capture as much of that as possible by utilizing those operators and those plant floor engineers to help you capture their knowledge and experience that isn't documented is critical. And then obviously, whenever you're going to change something, you're going to have some resistance. So once again, addressing stakeholders, which includes the end users themselves, their fear of change. One way to do that is with some small and visible wins. And then build internal champions. Make sure you've got someone on the team from both business ops and from IT. Too many times we see an engineer driving the driving the scope and the work and the definition of the scope and what even down to screen design, and they don't necessarily include the IT folks where the system's going to be running, or people from operations. So it's really important to have a cross-functional team that will be champions in their respective areas.
I couldn't agree more. The people on the floor are generally the ones that are going to have to live with the solution and interact with it on a daily basis, and so they should absolutely be involved in the process as you go along. And then from IT, they're going to have to support it, and so having them have a say in things as you progress, and having them be able to contribute how this fits within the broader ecosystem of systems from corporate perspective is also really valuable in these. I know a lot of implementers and people in ops tend to shy away from the IT involvement, but while that may make things easier in the short term, I think that it often adds some longer term challenges if you, have that avoidance. Any final tips as we go along?
Sure. So major one is to start small and demonstrate value. And usually, it helps to start with a low risk asset or a line to be able to prove that value. It may not be your highest payback at that point, but it's, once again, we're trying to go for some easy and quick wins. So starting small and on a low risk asset or a line is a good idea. And then leverage ignition tools early. So use the ignition's tag history, their transaction groups, and the alarm journal early in the development, so that you can learn what it's capable of doing, and it could easily simplify configuration further down the line, and especially as you start to scale. And then also prioritize your architecture planning. Don't skip architectural reviews. Plan for growth, redundancy, and security from day one.
Yeah, I couldn't agree more with that last point. I think that the start small to demonstrate value advice is often given to companies. And you and I, as Sesame Roadmap professionals, I think that we like to start with that architecture planning, looking at the big view for that company, and really understand how what we're doing in any small project is going to fit within that bigger picture.
Right.
What we don't want is to start small in 7 different areas of the company, with all of them focusing on their own kind of local problems, and then you end up with this mishmash of misfitting toys. And if you start with that big picture first, you can then still start small on a low risk asset or just a single line or something like that, to prove the value, but it's going to fit within that longer term picture and support the foundation that you're trying to lay for data management and everything else across the different parts of the company.
Couldn't agree more.
With that, thank you, Bob, for joining me once again. Look forward to the next time, as always. And if you in the audience want to reach out to us, there's contact information for Sandalwood right here. My contact information on LinkedIn, I'm just Tim Stewart. You can look for me with Visual Decisions, or my website is visualdecisions.com. Thank you all for joining. Thank you, Bob, most of all. And look forward to next conversation.
Same here. It's always a pleasure, Tim.
All right.